What's that kid? It's a very bad page.
6 cubed root negative 2. All right. This is number 6. Oh my goodness, thank you. So 2 doesn't have a cube that you can divide it by, right? But because this negative is under here, really the point of this question was that you know that the cube root of a negative number is a negative number. So you can just take the negative out. So this is negative 6 times the cube root of 2, and that's all you had to do with it. That's it. Yes, yes. Okay, so it's an odd root, so it wouldn't have an I, because what's the cube root of negative 1? Well, what times itself 3 times gives you negative 1? Well, you could make that negative 1. You don't need an I because you can do that. So odd roots never get I's. Even roots are the ones that get I's. Yep.
So what you're trying to do is
Yes.
and that's like how much you can.
Yes. Yeah, that's all you can do. Okay. Did everybody hear that? Do you understand? Odd roots do not get I's. Even roots get I's. Odd roots keep the sign of the number that's under the radical. That's all they do. Does that make sense? A little bit. Okay, give me another one. What else from your homework? 11. This is from the homework page, the side that looks like this. 3 times the square root of 252k5. All right, so I'm going to deal with the 252 first. Split it. Split it how? What'd you split it in? 36 and 7, which means that's 3 times 6 times the square root of 7, which is 18 square root of 7. Now let's look at this k to the 5th, right? What is the root outside? 2, because there's not one there, right? Everybody sees that? Okay, so how many times does 2 go into 5? 2. And how many are left? 1, so I keep that 1 under the radical. So now put everything outside the radical together and everything under the radicals together. So I have 18k squared times the square root of 7k. Sure. Hold on to myself. Hold on. I'm going to come right over here and do 6. Negative 8 times the square root of 63. Ooh. I thought 9 in my head because I saw the perfect square in it and wrote 69. Okay, so what's the perfect square that I can divide 63 by? I just gave it away. 9 and 7, so I've got negative 8 times the square root of 9 times the square root of 7. Square root of 9 is 3, so I have negative 8 times 3 times the square root of 7, which is negative 24 times the square root of 7. So since this one's forced negative here, we wouldn't. So if it starts out negative in the beginning, just leave it negative there all the way through. Did you say I told you so? Which one? 16. So if it starts out negative, it's forcing it negative, so just leave, you don't need the plus or minus. There's a 3 in there. You put it in the radical. Gotcha. Logan, which one did you say? 16. On the classwork side. So the 4th root of 48, M8 in 3. Is that the one? Okay. So 48 first. Can I split 48 anyway? 16 and 3. 16 and 3. What's the 4th root of 16? 2. I said this in 3rd block yesterday, and they said, don't say that, Miss Me, it confuses us. But a 4th root is just a square root and a square root. It's 2 square roots. So the square root of 16 is 4, and the square root of 4 is 2. It's just a square root. Anyway, if that confuses you, don't worry about it. How about m to the 8? M to the 2nd, because 4 goes into 8 twice. And then 4 goes into 3 how many times? None, and the remainder is 3. So you just leave it there. You can't really do anything with it. So this becomes 2m squared, fourth root of 3n cubed. Yes. What else? $15 on the homework side. The third root of negative r to the 14 s to the 9. And when I see this, because it's an odd root, I'm going to go ahead and pull that negative out, because it's just going to throw me off anyway. No i's because of the odd root here. So how many times does 3 go into 14? So I got the negative, so I got r to the 4th. How many are left? 2. And then how many times does 3 go into 9? 3 with none left, right? So this simplifies to negative r4s3 times the cubed root of r squared. Does that make sense? Right, yeah. Odd roots, I just always pull them out. I always pull them out for odd roots, and for even roots, I go and put the I out there. What else? Y'all good? Tell me how you feel about simplifying radicals like this. Good? We're not having a quiz today. I still haven't graded y'all's test, so. Which one? 14? On the homework? Classwork. The first page? So I've got the cubed root of negative 81 P2 Q12. Y'all should tell third block they have a quiz and it's really hard though. Okay. Cube root of negative 81. Is anything pull out there? Split anything up or anybody? Let me take the negative out first since I told you to do that. Can I split up 81? 27 and 3. So I got 27. This is on the classwork side. And 3. 3 goes into 2. No, y'all. They don't go in at all. 3 goes into 12 4 times. This becomes negative 3, of course. And the Q4. And then I've got the third root of 3p squared. Does that make sense? Alrighty. Y'all need a break in between? Y'all okay? A break? Alright, take a couple. Alright, so we simplified yesterday. Today we're going to add and subtract, but we're going to couple it with multiplying, which you've already done. So of course, you know, it continues to be the same thing, just gets a little bit harder as we go. Alright, here's the deal with adding and subtracting. You can only add or subtract when you have what we call like radicals. Kind of the same thing as like terms. So here's what like radicals mean. Like radicals mean it's the same root and the same radicand. So if it's the same root and the same radicand, what's different? What could be different? The what? Or the coefficient. That's exactly right, the coefficient. So if you look at something like 2 times the third root of 7, and I want to add it to 5 times the cube root. Oh, I shouldn't do all these 7s. Let me do 6 times. These are like radicals because they have the same root and the same radicand. What's different are these values out in front, which are the coefficients. So just what? What? Look on the desk beside my desk. I think they're stapled and sitting there. It starts with adding and subtracting radicals. Same root and same radicand. Sorry, guys. I didn't mean to leave y'all out. So when we combine these, we combine them just like we combine like terms. We combine the coefficients and we leave those radicals alone. So let me write that. We combine coefficients. So this would become 8, and then the third root of 7 stays. Just like if it was 2x plus 6x and the x stays, the radical stays. Does that make sense to you? Now don't start getting mixed up with addition and subtraction and multiplication, because if I multiplied these two, 2 cubed root of 7 times 6 cubed root of 7, what do I do? Multiply the coefficients, but isn't this just multiplication as well? Right? So this is really put together what's outside the radical. It's what you've been doing. So 12, and then put together what's inside the radical. 7 times 7 is 49. So we don't want you to start getting confused on the addition and subtraction as opposed to the multiplication. Does that make sense? Okay. So you've got 3 steps up there listed on there. Simplify all your radicals because they may not look like radicals initially, but they may be like radicals once you simplify them. And then we'll combine the ones that can be combined. So let's look at number 1 together. I have 3 times the square root of 27 minus 2 times the square root of 12. Can I combine those the way they are? Why? They're not like radicals. They don't have the same number under the radical, right? So my next thought is, okay, well, can I split them up? Can I simplify them any at all? Okay, so yes. 27 splits how? 9 and 3, which means this is 3 times the square root of 3, which is 9 square root of 3. Are we all okay there? How about the next one? 4 and 3. So this is 2 square root of 4 square root of 3, which is 2 times 2, which is 4 square root of 3. I'm still subtracting, right? Now what do you notice? Now you can do it. And you can do it now because now the root and the number under the radical are exactly the same. So what is 9 root 3 minus 4 root 3? 5 square root of 3. Does that make sense? See what we did? That's the extent of adding and subtracting. Let's look at number 2. 3 times the cubed root of 54 minus 2 times the cubed root of 2 plus 7 times the cubed root of negative 16. Do you see any like radicals? Nope, not right off. So my next step, see if I can simplify any radicals. How about the first one? Can it split at all? I hear no and yes. Who says yes? Okay, 9 and 6, well, it's a third root. 27 and 2, that's right. So I've got the third root of 27 times the third root of 2, which is 3 times 3. 9 times the third root of 2. Exactly what you were doing last night for each one of them, right? All right, this can't be simplified anymore, so I'm just going to rewrite this one, 2 cubed root of 2, because 2 can't split. How about this one? 8 and 2. That's exactly right. I'm going to go ahead and take that negative out. That's exactly right. And make this negative 7, 8, and 2. I did that because it's an odd root. So this is negative 7 times 2 times the cubed root of 2. So that would be minus 14 times the cubed root of 2. Now, everybody looks the same, right? So I can just do 9 minus 2 minus 14, which gives me what? Negative what? Mm-hmm. That's all there is to adding and subtracting. We'll do a couple more, make sure you got it. Let's do number 5. It looks kind of intimidating. I might look at this one and go, oh my gosh, I don't know. So let's try to simplify where we can. How about this first one, 98? Can you split that up into anything? What? 49 and 2. So I've got the square root of 49 and the square root of 2. Remember our little trick with variables. How many times does 2 go into 4? 2. And how many times does 2 go into 2? 1. 7 times the square root of 2, x squared y. So if I kind of put what's outside the radical together and then what's under the radical, I end up with 7x squared y square root of 2 minus 3x squared y square root of 2. What do you notice? They're the same, and in fact, they're the same for all of this stuff, right? Do you see that? So I'm just going to combine the 7 and negative 3 and leave all that I got boxed in pink there the same. 7 minus 3 is, and then the x squared y root 2. Don't get rid of it. It's still a variable, and it's, remember the definition of like terms are same variables, same bases, and they can have multiple variables in there. That's okay, as long as they look exactly the same. What do you think? Not too bad? Want me to do 6? Let's do 6. I've got the cubed root of negative 40 a to the 7 plus, come on, plus 2a squared times the cubed root of 135a to the 4th. Whoa. Okay, let's look at the first. Let's take it one at a time. I know I'm going to take this negative out of this one because it's an odd root. How about 40? Is there a perfect cube? 8 and 5. So cube root of 8, cube root of 5. And how many times does 3 go into 7? 2 times, and how many are left? 1 more a left. Everybody okay so far? Okay. Cube root of 8 is 2, so I've got negative 2 cube root 5, a squared cube root a. And so I'm just going to put what's under the radical together and what's outside of the radical together. So negative 2a squared. Everybody okay there? Okay, let's focus on the second piece then. 2a squared is outside, so I'll hold off on that right now. How about this 135a to the 4th? 27 and 5. So I've got 2a squared, 27, 5, and how many times does 3 go into 4? 1, and how many are left? 1. Two a squared. The cubed root of 27 is 3. I've got cubed root 5. I've got a, and I've got cubed root a. So now I have 6a cubed and then cubed root of 5a. Did I do that one right? Did I copy it right? A7, A4, A squared. Yeah. Because you've got an A, you've got these two A's here. You've got an A here. Yeah. So these look like radicals, right? But the problem is the numbers in front, this and this, are not the same. So I can't combine these two things. So I would just stop here. That one was a little bit tougher. All right, y'all ready to move on? Yes. Which one? Number 3. 7 times the 4th root of 48 minus 2 times the 4th root of 3 plus 3 times the 3rd root of 72. I noticed something that sticks out like a sore thumb from the very beginning. What is it? I've got a different root here, right? So I need to be very careful as I work my way through this one. But let's simplify each one individually. About 48, what 4th power can you take out there? 16. 16 and what? No. I'm talking to myself. How about 72? Third root 8? Yes, you're right. I'm sorry. 8 and 9. This is a 3rd root, not a 4th root. So don't let it throw you because it threw me. Okay, 4th root of 16 is 2. The 3rd root of 8 is 2. So I have 14, 4th root of 3, minus 2, 4th root of 3, plus 6, 3rd root of 9. Can I just do all the coefficients now? No, why? That one doesn't go. It doesn't belong. So it's got to just stay. But I can combine these two because they are like radicals. So 14 minus 2. And then I just, if you can't do it, write it and keep it there. So there's the final answer. That makes sense. All right, let's talk about multiplying. We've already talked, I'm not going to spend a long time on this multiplying because it's really just a review to help you to help you in what we're fixing to do when we start multiplying binomials. All right, so negative 3 times the fourth root of 64 times negative fourth root of 8. So there are a couple different ways you can go about these when they look like this. Oh, sorry. I can combine them to start with, and I can say, okay, 64 times 8 under the same radical, or I can split them up and then combine them. And it doesn't matter what you do and which one you do when, because it's just whatever makes it easier for you. So I'll do it both ways and show you, and you pick the way that you like the best, okay? So way one is I would do negative 3 times the fourth root. Actually, a negative times a negative is a positive, right? What is 64 times 8? What is it? 520? 512. Right? You see where I got that? 64 times 8. Now I can try to break this up. Is there a perfect fourth that I could take out of there? Think bigger. 256. So 256 times 2, which would be 3 times 4, which is 12 times the fourth root of 2, right? This is nothing new. This is what you've been doing. Now what you could do, say or, and you can pick which one you want. Sometimes this may look longer on this problem. Sometimes it's longer. Sometimes it's not. It's whichever you feel most comfortable in. Well, it's a negative times a negative, so it's positive. The other thing I could do is I could take this and I could split these up to start with. Okay, so I've got negative 3. 64, I could do what? 16 and 4? And 8, anything? And so then I have negative 3 times 4 times the fourth root of 4 times negative fourth root of 8. And now I could combine them. So 12 and then the two negatives. It just makes it a little bit easier to work with. Your numbers aren't as big under the radical if you do it this way. Then I could split this up. 16 and 2. What did I do? Oh, you're right. You're right. So this is 6. Thank you. That's 2. 4, 3, 2. This is 6. So it's 12. It comes out to be, in this case, it was a lot longer to do it this way, right? But over here, if these numbers start out abnormally large, then you're going to have a really big number under the radical that you're going to have to start trying to split up. But whichever way you want to do it, it really doesn't matter. Y'all okay? Yeah. Let's do one more multiplying. Make sure you got it. Let's do, what do you think, 13 or 14? 13. All right, I've got the cubed root of negative 3a7b4 times the third root of 36a6b2. They're both the same root, bless you. So I can just put them under the same one. Negative 3 times 36. What is it, 108? What is A7 times A6? Yep, that's right. Be confident. B4 times B2. You all see what we're doing? 108, can I split it up? 27 and 4. Cube root of 27, and I'm going to throw that negative outside. And 4. 3 goes into 13 how many times? 4. Looks exactly like what you were doing last night. 3 goes into 6. Oh, I forgot the remainder on the A. How many's left? 1. So I have negative 3 I'm going to just write it all out so you see where we're at. And now I'm going to put what's under the radical together and what's outside the radical together. So negative 3a4b2 times the cubed root of 4a. Y'all ready to kick it up a notch? Yeah. As we multiply with binomials, we're going to have to distribute, look for like radicals, combine like radicals, simplify. We're going to have to put all this knowledge together. So let's look at number 15. I have the square root of 10 times 5 root 5 minus 2 root 2. Uh-oh. What do I do? I'm going to distribute. So I've got 5 times the square root of 5 times the square root of 10. Right? And I'm taking this step by step so you see. And then minus 2 square root of 2 times the square root of 10. Does that confuse anybody? Put what's under the radicals together. Remember, and only when they're the same root can you do this, okay? So if this was a square root times a cubed root, you couldn't put them together under the same radical. So be careful there. But this becomes 5 times the square root of what? 50 minus 2 times the square root of 20. Now see, come on. Now see if you can simplify either one of them so we can see if we're in a position of like radicals. Okay, it doesn't usually take this long. 25 and 2, absolutely. Oh, come on. There we go. All right, so you said for 50, so 25 and 2. I still got that 5. Oh, good grief. Stupid weather. Yes. All right, you said 4 and 5. It's not working with me today.
But the internet communicates, and he's trying to start it. Oh, look at all their notes. But the struggle with it.
Okay. This is 5 times 5, which is 25 square root of 2. Like I need to write it really quick. This one is 2 times 2, which is 4, so minus 4 root 5. And what do you notice? Oh, they're not the same. So what? You leave it like that. You can't do anything else, yeah. If they were the same, you would combine them, but they're not, so stop. No, you can't, because they're not like radicals. The only time you can add or subtract is when they're like radicals. Yeah. Yes, if they cancel out, yes. Let's do one more of these, and then I'm going to set you loose, and I'm going to let you finish through 21 for classwork, and then your homework sheet is the second sheet just there that goes through. There's only 12 on that one. Let's do 19. It looks the hardest. Distribute, absolutely. So I got the square root of 3k times the square root of 12k minus 2 times the square root of 15k squared. Now, I could simplify some of these a little bit first if I wanted to. You don't have to. That's completely up to you. I'm probably just going to go ahead and distribute through. What is the square root of 3k times the square root of 12k? The square root of 36k squared. You all with me there? If they're the same and you're multiplying and they're both under the radical, yes. Now here, yeah, I skipped a step because my board kept dragging on me. Minus, bless you. What is square root of 3k times 2 square root of 15k squared? 2 Anybody confused? Let's simplify each radical now. The square root of 36 is, and 2 goes into 2 one time. It's just k. It's just 6k. Minus 2, how about 45? Does it break up? 5 and 9, that's exactly right. So I got 9 and I got 5. And how many times does 2 go into 3? How many is left? So this stays 6k. 2 times 3 times the square root of 5 times k times square root of k. Let's put everything inside the radical together and everything outside the radical together. 6k square root of 5k. And that's it, yes. Even though those 6k's are the same, I'm just going to stop there.